So from a high level, what we refer to, the core technology of Liquid is something referred to as composable infrastructure. Many of you may not be familiar with this term. What it refers to is a new way to build servers inside the data center. It's a new way of building data center infrastructure. Rather than building servers by taking devices and plugging them into the PCIe sockets of the motherboard, with composable infrastructure, what we do is we take pools of resources, pools of CPUs, pools of SSDs, pools of networking devices, and pools of GPUs, and instead of connecting them to a motherboard, we connect them to a PCIe fabric. And then we come in with software and we orchestrate or we compose physical bare metal servers from those pools of disaggregated resources. Grab this CPU from this tray, grab those 4 SSDs, grab me these 12 GPUs and those 6 NICs, and build me a physical server. Just like plugging stuff into the sockets of the motherboard, except you're defining it in software, and on the other side, you're being delivered a physical bare metal machine. Everything is dynamic based upon pools of disaggregated resources. What Liquid develops for composable infrastructure, number one is that fabric technology that interconnects all of these pools of resources, and number two is the software that allows you to orchestrate or compose physical bare metal machines. And we'll explain how this technology fits into the Jetson ecosystem. If you listen to what guys like Gartner are talking about, they're talking about composability as being that next generation data center architecture. Today, the big buzz is around hyperconverged and being able to spin up servers inside your environment with using the hyperconverged technology. As we move forward, it's very much going to be around a composable world. Being able to dynamically resize your physical infrastructure to best match the workload that you're looking to deploy. When your server runs out of storage, don't send a guy with a cart to plug in more storage. Reprogram your fabric and suck in more resources. The big guys, Google, Facebook, Amazon, they figured it out. They've realized that moving forward, static infrastructure is not how the data center is going to be built. We're not going to deploy a static server into the environment and hope that for the next 3 or 5 years that static configuration best fits our workload. What we're going to want is to be able to dynamically resize and reconfigure that server on the fly to dynamically match the workload that we're looking to deploy. In order to make this composable landscape happen, there's 2 core pieces of technology that need to be developed. First is the fabric that allows you to interconnect all of the devices in the data center. And number 2 is that software that allows you to orchestrate or compose at the bare metal. For a fabric, the way that we interconnect the boxes inside the data center, we've chosen our fabric to be PCIe for a very simple reason. Compute always had PCIe coming in and out of the root complex. Where do networking cards plug in? PCIe bus. Where do GPUs plug in? Into the PCIe bus. Now that storage has migrated to NVMe, it's the first time in the data center we have everything on a common bus. Storage, compute, networking, GPUs, they all live on a common interconnect, and that common interconnect is PCIe. That's why we've chosen our fabric, or the way that we interconnect these disaggregated pools of resources, to be PCIe, is because now we can orchestrate without electrical translation, without protocol translation, without virtualization, being able to compose servers at the bare metal with the native interconnect that the devices were built upon. This is our belief, the first time in the data center, everything is on a common bus. It's never happened before. What Liquid builds is a PCIe fabric and the software to orchestrate. That switch that you see there, that is our IP. Our software lives inside that switch. To this switch, we connect off-the-shelf pools of resources, a tray of SSDs, a tray of NICs, a tray of GPUs, a tray of compute, all connected to our switch. At power on, our software says, here's everything connected to the fabric. How would you like to orchestrate your machine? How many CPUs, how many GPUs, how many networking devices do you want connected in that server? And oh, by the way, it's dynamic. Set a policy in place that says when that server goes above 80% storage used, automatically reprogram the fabric, give me more storage devices. At 10 o'clock at night, when I know no one's using those GPUs, automatically reprogram the fabric, suck out those GPUs, and let's go do some crypto mining. Whatever it may be. Let's get 100% utilization out of the resources that we're deploying into the data center. The only way to do that is make everything dynamic and, and flexible, right? So that's what we developed, is that fabric technology based around PCIe and the software that allows you to orchestrate at the bare metal.